Let us do a very important concept and we'll discuss it. It is very simple. Let's understand. It says that it is something called a similarity of right angle triangles. That means it is going to deal with right angle triangles. Now this is nothing but it's a theorem, so it will have a statement. That's a beautiful statement. It's a very simple one. Don't worry about the length of the statement. It is going to be very easy, provided we understand it. Now let's read the statement. Let's understand what we are supposed to draw. We are going to prove this theorem. So we need to understand what is the given, what is the to prove, and then we'll prove it, right? Let's understand this. It says in a right angle triangle. So that means the very first thing is we have a right angle triangle. So let's consider right angle triangle. Now tell me, is this triangle right angle triangle? Yes, because one angle is 90 there. Yes. It says if the altitude is drawn to the hypotenuse. Now there is if and then. That means whatever is between if and then, that is nothing but the given, and whatever comes after then is nothing but the to prove. So let's understand. What are we supposed to draw more? It says if the altitude is drawn to the hypotenuse. Now in this right angle triangle, tell me my dear child, what is the hypotenuse? The hypotenuse is AC, the side opposite to the right angle, right? They say there is an altitude drawn to the hypotenuse. That means there is a perpendicular drop from this B onto the hypotenuse. That is the altitude on AC, right? That's what we got. The altitude drawn on the hypotenuse, that is given to us. So let's, whatever we have drawn, that is nothing but the given. So let's write the given. In the given we're going to write, we have a right angle triangle. So we write in triangle ABC, angle ABC is equal to 90 degree. What else do we have? We have segment BD perpendicular to hypotenuse AC such that A dash D dash C. That's what we wrote. So we understood what's the given. Now let's understand what are we supposed to prove. That comes after then. It says then the two triangles formed are similar to the original triangle. Now because of this altitude, do we have two triangles here? We have this triangle and we have this triangle, right? The two triangles which are formed, they say are similar to the original triangle. What's the original triangle? The original triangle is ABC. So let's write. So what are the two proof? First, let's consider this triangle. That means you are talking about this triangle, right? Triangle ADB. This triangle is similar to the original one. That means it is similar to triangle ABC. Same with the other one, the other smaller one, that is triangle BDC. That's similar to the original one, that is triangle ABC. Beautiful. What else? It says further, and to each other. That means each of this triangle, they are similar to the original one and also similar to each other. That means we are saying that triangle ADB is similar to triangle BDC. That is what you are supposed to prove. So there's a lot to prove. We have to prove three things. Difficult? No, it's going to be very easy. Let's understand. Let's consider the first one. Let's consider the first pair of triangle which we need to prove similar. That is triangle ADB and triangle ABC. Let's make it very clear by highlighting it. So we have the bigger triangle ABC and we have the smaller one which we are considering triangle ADB. Now we need to prove them similar. Tell me first, there's no information about the sides. So it has to be angle. And when we talk about angle, which test? Yes, you're talking very correct. A test of similarity. So let's see if we have got any one pair of angle equal first. So you have a common angle there for both, isn't it? When we consider this, that is angle A. Isn't that the common angle? Observe very carefully. Yes. So for both the triangles, we have a common angle. So we write there, angle A is congruent to angle A. Why are they congruent? Because you know the reason is common angle. Any one more pair of angle which you get equal, you will say yes, very easy. You know why? Because you see this angle is how much? 90. And you see this angle, how much is this? 90. That means in both the triangles, there's one more pair of angle which is equal. So we write that angle ADB is equal to or congruent to angle ABC. Why are they congruent? We know the reason is nothing but each is 90 degree. So hence, in both the triangles, we got two pairs of corresponding angles congruent. That means we know that both the triangles are similar. So we write there triangle ADB is similar to triangle ABC. And why are they similar? We know the reason. The reason is nothing but by a test of similarity. Now my dear child, when we write the triangle similar, right, we need to write as per the one-to-one correspondence. And the correspondence here was very simple, right? Common angle. That means A corresponds to A. A corresponds to A. Now, in the smaller triangle that 90 here and in the bigger triangle that 90, they correspond to each other. That means D corresponds to B. So we have D corresponds to B and then the third vertex is the remaining one. Was that easy? So we got it. So you said yes, we got the first one. Now let's go for the next one. Next pair of triangle. Let's consider that. the smaller triangle and the bigger triangle. Let's consider that. Triangle ABC and triangle BDC. Now I want you to tell me in both the triangles, if I consider this, which angle, you have a pair of angle which is equal, which is congruent. Yes, you have that angle C. Why? Common angle. So you write angle C is congruent to angle C, and the reason is common angle. Beautiful. What else? Do we have one more pair of angle which is congruent? Yes, because you see an angle here, this is 90, and you see an angle D here, this is 90. Both are equal, both are congruent because each is a right angle, right? So we write that angle BDC is congruent to angle ABC, and the reason is each is 90. That means we say that both the triangles, they are similar to each other by a test of similarity. Again, remember the correspondence. In this triangle BDC, in the smaller one and in the bigger one, we have the common angle. So C corresponds to C. C corresponds to C, right? Then this 90, that is D, corresponds to this B. So D corresponds to B, and that's the remaining one is nothing but the third vertex which is there. Was that easy? Very simple. You said so simple, right? So we proved 2, but we need to prove the third, right? We need to prove the third. How do we get that? Difficult? You will say we'll consider both the triangles, this one and this one. No. Observe what we got in result number 1 and result number 2. In result number 1, we said that triangle ADB is similar to triangle ABC. And what do we have here? Triangle BDC is similar to triangle ABC. Two triangles similar to the same. That means this triangle ADB and this triangle BDC, they are similar to each other. So we write that from 1 and 2, we have the triangle ADB and this triangle BDC, they are similar to each other. From where? From 1 and 2 we got that. What do you mean by that? That means, in other words, we are saying that all the three triangles, they are similar to each other. And that is what you learn from this theorem. So what this theorem tells us is very simple. It says that whenever there's a right angle triangle, right? Remember, whenever there's a right angle triangle, in that right angle triangle, whenever we drop a perpendicular on the hypotenuse, remember the condition. It should be a right angle triangle. There should be a perpendicular dropped on the hypotenuse. In such a case, all the three triangles which we get, how? Three triangles, the two smaller one and the bigger one, all of them are similar to each other. And when we write them similar, we can just write the reason into bracket as similarity of right angle triangles. When we present this theorem in any sum, the way to present is very important. First, we should write the name of the triangle. So we should write in triangle ABC, angle ABC is equal to 90 degree. Then we should write segment BD is perpendicular to hypotenuse AC. So in the next line, we'll write all the three triangles are similar, and into bracket we write the reason as similarity of right angle triangles. Now that's very easy, we understood this, okay. But the most important thing is, the most critical thing is, we know when we write the triangle similar, it has to be as per the one-to-one correspondence. Now here there are three triangles which we are writing similar. How do we write it? Are we going to check the correspondence? No, I'll give you a trick to write it correctly, so that you need not think much. Now this trick is going to be very easy, observe very carefully. So what I'm saying is that we have a right angle triangle. In that right angle triangle, there's a perpendicular dropped on the hypotenuse, isn't it? So here, can we apply similarity of right angle triangles? Yes, we can. That means we are saying that all the three triangles, the two smaller one and the bigger one, they are similar to each other by similarity of right angle triangle. But the question is, how do we write the triangles? Let's understand that. Very simple. Observe. What we do is, the trick is, first write the name of the bigger triangle with 90 degree angle in between. What is 90 degree angle? That is B. Write that in between. So we write it as triangle ABC, or we write it as triangle CBA. But remember, 90 degree will be in between. Once we write this, now you are saying, yes, I want the name of the other two triangles which are similar. How do I write it? As per the correspondence. Beautiful. See the trick. The trick is, now in this triangle ABC, the three vertices ABC, what is the fourth point which you see because of that altitude? That is D, right? Pick up that D. Focus on that D. Pick up that D, place it between the first two alphabets there. So what do we get? We get a triangle. What it will be? ADB. What's the name you get? ADB. That's the name of the second one. That easy. You know what you'll do next? Yes, pick up the same point D and place it between the next two. That means, what's the name of the triangle we get now? BDC. Beautiful. That's the trick. That's the way you write the name of the three triangles similar to each other with one-to-one correspondence between the vertices. Is that easy? Isn't that easy? Very simple, right? Beautiful. Let me give you one more example, and this time you're going to tell me very carefully how you're going to write the name of the three triangles. So that's it. Can we apply that theorem here? Yes, we can, because there is a right angle triangle, there's a perpendicular dropped on the hypotenuse. Yes. So first, very important, write the name of the bigger triangle with the 90 degree in between. We wrote that, PQR. Beautiful. Now we want the name of the other two triangles. How do we get that? Very simple. What do we do? Pick up the fourth point there, that altitude one. What is that? S. Pick up that S. What do we do? We place it between the first two there. What do we get? The name of the second triangle is PSQ. Beautiful. Pick the same, write it between the next two, and what do we get? Triangle QSR, and we end up getting the three triangles which are similar to each other. Wasn't that easy? It's a beautiful one. Remember, when do we apply this theorem? In a right angle triangle. What is the second condition? We should have a perpendicular on the hypotenuse. In that case, we can write the three triangles similar by the trick which we learned right now. But remember, into bracket we should write the reason as similarity of right angle triangles. Easy. It's a very important one.
And yes, please do not forget to like, share, subscribe, and press the bell icon.